Good morning. Today we're going to be starting with chapter 13, and this chapter deals with graphing quadratics. And so before I go into any of that, I want to remind you that if you have any work that you've missed, make sure you catch up on that. I have everything in Infinite Campus that I can see right now. As you complete things, though, please email me and tell me you've completed it so I can check it and update it in Infinite Campus. Okay, so back to graphing quadratics. Now we're slightly familiar with this because earlier in the year we talked about what a quadratic looks like. First and foremost, we remember that our quadratic is when we have x squared. If you remember, we talked about the different types of graph. X was linear, x squared was a quadratic, the absolute value of x was an absolute value x, and then when we had a square root around an x, it was a square root graph. So we're learning how to graph the quadratics. And if you remember what the look of it is, it's always a U shape, whether it opens up like this one or whether it opens down like this one. But both of those are quadratics. Now that we remember what it looks like, we're going to talk about a few key things about the quadratic. 4 terms. First of all, and most importantly, the vertex. We need to understand what the vertex is. The vertex represents always either the lowest point or the highest point and where it starts to curve. In this case, our vertex is at the point 2, -5. We always write the vertex as a point. Now, if our graph opened up, then our vertex would be at the top. And so at this case, our vertex would be at -7, 5. But our vertex is always a point. Now, speaking of the vertex, we also look at the fact that it represents our minimum or maximum value. Our vertex is always going to represent either the lowest point or the highest point based on whether it opens up or opens down. In the case of the graph here, it's our minimum point because it's the lowest point on the graph. In this case, our vertex is our maximum point because it's the highest point on the graph. Those are two very important terms to understand. Now, continuing with the 4 terms, parabola is just what we call the shape. When we graph a quadratic, the resulting shape is what we call a parabola. Parabola just means a U-shaped graph. The last one, the axis of symmetry, is very important to understand as well. The axis of symmetry represents an imaginary line that is a vertical line passing through the vertex. Now, if you notice, the graph looks exactly the same on both sides of that line. It's symmetrical on the right and left, which is why we call it the axis of symmetry. And so it helps us out when we start graphing it. Whenever we ask for the axis of symmetry, it's always the equation of that line. And since that line is a vertical line, we always start off by saying x equals, and in this case, since it passes through 2, it's x equals 2. In our graph over here, since our vertex is at -7, 5, our axis of symmetry is x equals -7. Now back to our minimum and maximum. When we look at the graph. If A is positive, the parabola opens up. So let's make sure we take a look at that and understand that. We've talked about different forms of our quadratic. Standard form is what we were factoring in to start with. And if you remember, our standard form was always ax squared plus bx plus c. We talked about the a, the b, and the c, since we were also talking about using those in the quadratic formula. The vertex form of a quadratic we looked at and we solved, but the a is any number that's being multiplied in front of the parentheses. Typically, our a is 1. However, we have had some equations that we've had that different than 1. If a in either equation is positive, then that means the parabola opens up, which means that our vertex is our lowest point, so it represents our minimum value. If, on the other hand, a is negative, and we have an equation like this, if a is negative, that means our parabola opens down, which means that our vertex will always be our highest point or our maximum value. So let's take a look at a couple examples. In example 1, we look for the vertex, and again, the vertex is either the lowest point or the highest point, but it's where the graph starts to curve. So in this case, our vertex is at -3, because we go to -3, and then we go down to -2. So our vertex is at -3, -2. Because the graph opens up, that means our vertex is at the lowest point, or a minimum value, and it opens up. And then our axis of symmetry, again, is always a vertical line through our vertex. So in this case, x equals -3. Why don't you guys try the next one? Okay, well, let's see how you did. First of all, when we take a look at our parabola, we notice that it opens down. Therefore, we know it opens down, and our vertex is at its maximum point because it's the top of the parabola. Next, our vertex is at the point 4, 6. And because our axis of symmetry is a vertical line through our vertex, we know our axis of symmetry is x equals 4. How'd you do? Hopefully you did great. So, a couple more things that I want to point out, and that happens to be our x and our y intercepts. Now, you guys know what those are, so I'm not going to spend a lot of time on those, but I'm going to give you the different possibilities. Now, if we look at this graph here, both the x and y intercept seem like they might be a little bit harder to find. In this case, our x-intercepts don't fall directly on a number, and so if we had to figure out what those were, it would take some math. We can't just look at the graph and tell you. Our y-intercept, on the other hand, seems to be at 0, -9. So let's take a look at a graph that has some x-intercepts that are a little bit more visible. If I had this graph, then I would see where my two x-intercepts are. Now, typically, a parabola has two x-intercepts and one y-intercept. However, we do have graphs that only have one x-intercept or no x-intercept. Let's take a look at what I could do. If I drew a graph like this, then we'd only have one x-intercept because that's where our vertex would lie. I could also draw a graph like this that had no x-intercepts because it doesn't cross the x-axis at all. And so we can have a possibility of 1, 2, or 3 x-intercepts. And again, typically we will always have a y value because we know when it comes to domain and range, no matter how far we go down or up, it's eventually going to get across the y-axis and have a y-intercept. So I hope you guys are doing well. I hope you guys enjoy your weekend, and we'll see you on Monday.